This video covers the application of one sample Ttest with the assumption of normality, which is required for applying any kind of Ttest. So our main concern is with the one sample Ttest. So here we go. We discussed so far that hypothesis testing, which is concerned with making the statement regarding population parameter and based on sample data and then verify and nullify it. Like if our hypothesis is that the mean blood pressure is equal to 120 millimeter Hg, so this is a statement, and we have to later verify or nullify this statement using sample data. So for that purpose, we also discussed that we have 6 steps to conduct the hypothesis. One is first one is that statement of hypothesis, either null hypothesis and alternate hypothesis. Like in our example of the mean is equal to 120 millimeter Hg, the null hypothesis uh, is the mean mu is equal to 120, and alternative is mu is not equal to 120, because null contains the equality in the statement, and the alternative contains the non-equality in the statement. The level of significance are set usually as 0.05, 0.01, 0.10, but mostly we take 0.05. It is as commonly. Statistics. We are going to discuss the case of the one sample t-test, and but the assumption of t-test requires the normality test to be tested, that the data must follow a normal distribution, like the variable which we have that follow a normal distribution. So we have different tests to check the normality. For example, we have the box plot and histogram. For example, the histogram, if it shows the bell-shaped curve, or we can say the symmetric curve, we can actually make a decision that it follows a normal distribution, not like this, which is like a skewed distribution. And we have also the measures of skewness, like if the values lie from minus zero point 0.2 to plus zero point 0.2, we will say the data is symmetric, or we say normally distributed. If it is not, then it would be either less than minus zero point 0.2 or more than 0.2. It is then skewed data, so we cannot apply the t-test. Similarly, we have the inferential method like this pp plot. The pp plot, if all the points are on the line, then it is normally distributed. If it is not, then if it is like S-shaped curve, it is a non-normal distribution. Our concern for this lecture is more on the inferential tests, which are Shapiro-Wilk test and Kolmogorov-Smirnov. So this is one of the inferential kind. So we will start with the assumption that data follows normal distribution, and if we get the p-value more than alpha, so we will say the data will follow the normal distribution, otherwise not. So t-test, we just studied that it requires one of the assumption that the population should normally distributed, and the quantitative variable is compared with standard single value. So we apply the one sample t-test. We had the example of the sleeping time, which is here, that the average sleeping time is equal to 8 hours was our hypothesis, and the data values of the 10 students were here. So we have to first check whether this data follows normal distribution or not. If it follows the normal distribution, we will apply the t-test. So for checking the normality, we have two tests. One is Shapiro-Wilk test, another one is Kolmogorov-Smirnov test. So for small sample size, it is recommended to use the Shapiro-Wilk test, which we have in our scenario. To check the normality using the Shapiro-Wilk test, we have to use the SPSS, and we have the analyze option. In the analyze, we have the descriptive statistics, and then we have the function of explore. When we click the function of explore, a dialog box appears, and we have to transfer our variable for which we have to analyze, which is sleeping time here, in the dependent list box. And then we have one more option like plots. In the plots, we have this option normality plot with test. So we will click on the normative plot with test and we will press continue and then we will press OK. In this output of the SPSS, there will be too many tables and too many graph appears. We have to look for the table which has the value test for normality. In the test of normality, the sig value is nothing but the p-value. So we will see this one, like we have the hypothesis, if p-value will be more than 0.05, we will accept that the data follows normal distribution. Here, our value is 0.479, which is more than 0.05. It implies that data values which are the sleeping time in our scenario. So the sleeping time follows normal distribution. This analysis, the Shapiro-Wilk analysis, give us the uh, green signal to apply the one sample t-test. So now we can proceed to the one sample t-test, which we have the hypothesis, and we will follow the same procedure of defining the step of hypothesis, which are step number one is we will define the null hypothesis and the alternative hypothesis. The null hypothesis is that if the student sleep for 8 hours, and alternative is that the student does not sleep for the 8 hour. Level of significance 0.05 because it was not mentioned in the question. Test statistic is one sample t-test because we have the one quantitative variable which is normally distributed. We check for the Shapiro-Wilk test, and that normally distributed quantitative variable is going to be checked with the value of null hypothesis. And the rejection region is that we will reject the null hypothesis if p-value from this one sample t-test will be less than 0.05. So we will run the analysis in SPSS using the option analyze, and we will use the option compare means and in one sample t-test. In the one sample t-test, we will transfer the sleep to the test variable list. And in the test value, we provide here the hypothesized value, which is the 8 hour at this moment. We'll press OK. After pressing OK, we will we will get this output. One is descriptive statistic, another one is the inferential statistic. This sig value is nothing but the p-value from the t-test, which is, and from the output was 0.000, which we have edited to less than 0.0001 because the p-value cannot be exactly 0. So we write it as p-value as less than 0.001. So our conclusion is that the result p-value is less than alpha. So sleeping time of students shows statistically significant difference from hypothetical mean, which was 8 hours. This is our video. This is our lecture so far. So for the next time, we are going to meet with more than one sample test.